We're going to go ahead and I'm going to play a quick video here. It'll be about 5 minutes or so. It'll be kind of a buffer that we use between now and when we'll start the show. So Trent Pittman will be here in just a second to go ahead and get us started. But in the meantime, we'll just watch some interesting weather videos that just come along.
Hey guys, I'd like to thank everyone for coming out tonight to the 2018 Storm Spotter Talk in Johnson County. This evening's presentation is unique, and then this presentation is both entertaining as well as highly informative. Before I introduce Jared Leighton, I'd like to again thank everyone for coming and attending today's presentation, because it's a very important step for becoming better prepared for severe weather season. As Jared will touch on shortly, we're no strangers to severe weather and adverse weather in Johnson County. Just about a year ago, on March 6th last year, Johnson County experienced strong straight-line winds of 85 miles an hour in both DeSoto, Kansas, Olathe, Kansas, as well as Overland Park, as well as a EF0 tornado that actually occurred in Leawood. And then again in July as well as August, we again experienced strong straight-line winds that were 85 miles an hour, as well as extreme flooding. I'm sure we all remember a lot of the water rescue videos that we saw in the news from Leawood what occurred around 435 and 103rd Street. That event actually resulted in the first presidentially declared disaster in Johnson County since the ice storms in the early 2000s. Understanding severe weather and how to prepare for it is just another important step of living in the Midwest and the Great Plains. Another step you can take to become better prepared is to get involved. Johnson County is fortunate in that we have a number of ways you can get involved, including community emergency response teams, or CERT teams. Have any of you guys heard of what a CERT team is, or a part of a CERT team, in fact? Yeah, there are a number of teams around Johnson County, both in southwest Johnson County, in Olathe, and Overland Park, and in Shawnee. There are a number of ways you can get involved with those organizations. They can teach you how to be more self-reliant for yourself and in your neighborhood, as well as in your greater community as a whole. So you can get out there and help people following an event or a disaster. Another way you can get involved is to work with an organization called Johnson County ECS. They act as the official storm spotting organization for Johnson County Emergency Management. And when we come into the office for severe weather, they're right out there in the field reporting back to us what they see. And in fact, they've seen some pretty good stuff in the past few years. Herb Finnett here from that organization here will just take a few moments to let you know what it is they do. Thanks, Herb.
Okay. Thanks, Trent. As Trent indicated, this evening's presentation is supposed to be entertaining and informative. And just looking around, I think I may be the entertainment tonight, so we'll try to make this good. As Trent indicated, I'm a member of the Johnson County Emergency Communication Service, what we call ECS. That is an amateur radio-based organization that is allied with the county, and they use us for storm spotting when there's significant weather occurring. Many times each year, at the request of emergency management, people like Trent and other people on the staff of emergency management, we deploy out into various locations within the county and report back significant weather events via amateur radio. So that's first requirement. If you're interested in doing something like that, you need to be a ham radio operator. That requires an FCC license, but that's pretty easy to get. And then there's some other specific training requirements that we require to be a member of ECS. So we have some handouts out front. You can find me or one of the members of ECS out there. We all have these kind of gray polo shirts on, and some of us have the bright green hats. I prefer not to cover this up. I kind of enjoy it. But you can look for us out front after the presentation. We'd love to tell you more about it. But as Trent said, it's a great way to get involved, and you can join the 75 or so other members of Johnson County ECS and get directly involved with Johnson County Emergency Management staff. So if you got any questions, you can see us after the presentation out front. Thanks, Trent.
All right, guys. Well, I won't spend any more of your time up here babbling. So I'd like to go ahead and introduce Jared Leighton with the Weather Service. He's been in the Weather Service for 13 years now as a meteorologist with both in Sacramento, Topeka, and now in Pleasant Hill, Kansas City. In his time off, he likes enjoying some time chasing, and is actually quite an accomplished photographer out there. Jared?
Thanks. All right. Just so I get this lapel mic working here. Does everybody hear me okay now? Everybody good? Good. All right. I'm going to dual hand it here because I need a laser and a clicker. So, let me see for my ambidextrous. All right. So, welcome. 2018 Storm Spotter Training. Anybody here for the first time? Oh my gosh, it's a lot. Okay. No, it's great. I love to see new people. If you've already seen this talk before, a lot of it is we're replaying it from last year. Some of it is new, so it's not all completely repeated, but it still accomplishes the task of reminding everybody about severe weather. I know we're in January. I know it's 12 degrees outside or whatever unknown cold temperature it is, but March is coming fast, and if everybody remembers, last year March was a really bad severe weather month for the area, so we're really only about 6 weeks away from severe weather starting to impact our area again. Okay. So just a quick agenda. We're going to be looking at we'll introduce why spotter training is important, why spotters are important to us at the Weather Service. We'll look a little bit of the 2017 in review. Trent already went over some of the major events, especially for Johnson County. Johnson County was one of our kind of hot counties as far as severe weather last year. We'll go into some thunderstorm basics, some meteorology 101, just kind of talk a little bit about how thunderstorms form in the first place, what makes them dangerous, why they kind of have to follow a set of rules. We'll look at some ID features. Situational awareness is always really important as a spotter, whether you're stationary or whether you're mobile. Okay? It's always important to remain aware of what's going on around you. We'll look at some resources, some things you can look at to keep you aware of what's going on weather-wise across the area, some safety, and then exactly how to report. Did everybody get one of those little cards on the table up front? If not, grab one. It has a phone number on it. That's a direct line to one of our forecasters in the office. We're one of the only government agencies that I can think of, especially on the federal level, where you can actually dial a phone number, get the person you want on the line immediately, no boxes to talk to or numbers to dial or anything like that. So use that number, put it on your fridge, put it in your phone, whatever, and if you have some kind of weather to report, dial it up and let us know. Okay? We're not going to take a break tonight, so I'm going to try to get through this as quickly as possible. It's usually about 75 to 90 minutes. We'll do a Q&A at the end. I'll be here as long as you need me to answer questions, tell stories, whatever you want to talk about. There'll be a few survey questions throughout the talk. There won't be too many. More of a show of hand type thing. I'm not going to call on you to answer anything specific. But if you want to participate, cool. If not, it's fine too. If you have a cell phone, go ahead and turn it off. That'd be great. So what do we do with the National Weather Service? If you haven't heard of the National Weather Service, we're the ones that are responsible for all watches and warnings that go out across basically the entire United States. For our particular office in Kansas City, we're actually located in Pleasant Hill, which is a little south of East Summit. It's kind of out in the rural areas. But we're responsible for all of the Kansas City metro area out to Columbia, basically from Bates County all the way up to the Iowa border. That's our domain that we issue severe weather and winter weather warnings and watches for. Okay? So we essentially push the warnings to the emergency management community, who then push out to you or to the media. So usually those warnings originate in our office. So why do we need spotters? Why are we even here? Is this just an entertainment show? Well, yes, in some ways, but also we find spotters to be really important for a couple of reasons. As you can see, our radar is a nice piece of equipment. It's a several millions of dollars piece of equipment that gives us a lot of information about storms, not only real close to Kansas City, but way far out from Kansas City as well. But because of the curvature of the Earth, as that radar beam goes further and further away from its source, it's getting higher and higher and higher up in the atmosphere. So we have a tale of two storms here. One storm is really close to the radar, one storm is way away from the radar. What do you notice about the radar beam as it starts to approach Storm B, say in Kirksville? Okay, Storm A is probably something you might see here in Kansas City, pretty close to the radar. And then we got Storm B out here, probably in Kirksville or Columbia or up toward Tarkio or Maryville. Okay? So what do you notice about the radar beams as it goes from A to B? It gets a lot higher into the storm. Where would you suspect a tornado would form in storms? Probably in this area here, between the storm cloud and the ground. So what do we not see with the radar in Storm B? Exactly where the tornado would be. So when you get far away from the radar, say 60 miles, 80 miles, 100 miles, which is what we're talking about with Columbia or Macon County or even up toward Iowa, you're getting a much less complete view of the storm than what you get really close to the storm. So that's why spotters are really important. Okay? Now, there's two things that spotters add to every warning that we send out. So whenever we see a storm that we suspect is capable of producing a tornado, we'll issue a tornado warning on it, which then goes to the media, then goes to emergency management, and then off to your cell phones or whatever method you use to get those warnings. Okay? Well, spotters add two elements that make those warnings better. One of those elements is being able to fill in some of the blanks. So, for example, we have an environment that says there could be some tornadoes. There's a tornado watch out, and the shear is very strong, the instability is very strong. We're saying any storm could potentially produce a tornado. And then the radar says, there's something spinning out there. You guys, it looks like it could be a tornado. we'll probably issue a tornado on that. The environment says it's supportive of tornadoes, and the radar says it's supportive of tornadoes. Boom, there goes your tornado warning. It's not always that clear cut. A lot of times, you'll be in an environment that says tornadoes aren't that likely today, but then the radar says there's something spinning out there, so we're like, that's kind of conflicting, right? Well, if someone is out there looking at it and they say, you know what, by golly, I can't believe it, but there's a tornado, that helps us break the tie between some conflicting information. So likewise, if the environment is conducive for tornadoes, we're saying there's a tornado watch, we could see a few tornadoes today, but the radar's not picking it up very well, and a spotter comes out and says, you have a tornado, that might break the tie, again, with that conflicting information. So it's very important for those spotters to give us that information as quickly as they can. The other thing it does is it adds credibility to a warning. Okay, if we see a storm spinning on radar, and we think, okay, it's time to go with a tornado warning. It's spinning hard enough that we are confident that it could produce a tornado here in the next 10, 15, 20 minutes. Okay, that should get you in action. But honestly, what's more likely to get you into action? Something like that, or if a warning said, trained spotters have seen a tornado, it is moving through Edgerton, it is heading toward Olathe, it'll be there in 10 minutes. Which one of those warnings would get you more likely to your basement?
Ladder.
The second one, right? The first one is we think there's a tornado. We think there's a tornado. The second one is we know there's a tornado and it's heading right for you. Okay? So without that confirmation, we can't add that level of credibility. So it not only adds confidence to our warnings, it also adds credibility. It helps your favorite TV meteorologist get on the air and say, okay, Olathe, tornado is on the ground, we have pictures of it, and it's heading toward your city. It'll be there in 10 minutes. Okay? All that is really important to get people to take action. So again, I'm telling you this because I want everyone to take pride in being a spotter and helping out the Weather Service, helping out Johnson County. It's wrong one. There we go. So as I mentioned earlier, I won't dwell too long on this slide. I talked about this back on the What We Do slide, which is the NWS. We send out the watch and the warnings. It goes to the EM community, so Trent and whatever county you're dealing with, that county gets it and they can sound the sirens. And then it can go to the media. So again, you're watching your favorite TV meteorologist, and they get on the air and they're putting up our boxes and telling you, hey, the Weather Service has issued this warning, that warning. Okay, so that's how basically the system works. So quickly, I'm going to go into a little bit of year in review. Now, I find this to be important, not just from an entertainment standpoint, but also as like I said, a reminder. Okay, it's been cold for the last 3 or 4 months. We've seen I saw a few snowflakes today. Severe weather is not in anyone's mind. It really isn't. But again, we are very close to getting those storms back in the area where we can actually get some severe weather. So, a little bit of 2017 in review. Warnings. So our office issued 300 warnings last year, 40 tornado, 220 severe thunderstorm, 40 flash flood, which were all pretty close to average for the last 5 years. Okay, so 300 is our average for total warnings. We issued a few more tornado warnings than average, and then severe thunderstorm and flash flood were pretty close to the same. The maximum EF rating was EF3. Okay, and our area is basically northwest Missouri, again from Kansas City to Columbia, Bates County up to the Iowa border. So all these stats are just for this part of Missouri. St. Louis has an equally as big piece of Missouri, and Springfield has an equally as big piece of Missouri, and they all have about the same stats. A lot of severe weather happens in the state of Missouri every year, right? So the maximum EF rating was the EF3 tornado that hit Oak Grove. Everybody remember that on March 6th? Okay, it was the same day Trent was talking about with the Leawood tornado. Our largest hail size last year, May 27th, down in Bates County, kind of near Adrian. And then the strongest non-tornadic thunderstorm wind we got was about 89 miles per hour. It was actually measured by a utility company. I don't know if it was on top of a windmill or whatever equipment they had out there, but 89 miles per hour was the strongest non-tornadic wind speed we observed. So I'm going to talk a little bit about March 6th. That was a big day across Kansas City. Probably, in my estimation, I do most of the documentation for storms for our office. And the closest day I can find to something that was this busy was March 12th of 2006. So roughly an 11-year gap between events like this. Okay. We had at least 12 tornadoes. And I say at least because there was no way that our office could go out and survey everybody's damage. Okay? These are the ones we were able to confirm. The big one was the number 5 here in Oak Grove. Number 3 was up in Smithville and Lathrop. Okay? We issued 19 tornado warnings that night. Now, to put that in perspective, for the years of 2012, 13, and 16, we combined for 19 tornado warnings. So 3 years. Granted, they were a little low on the severe weather spectrum, but 3 years we combined for the same number of tornado warnings as we issued just on that one night in March 6th. My estimation, and again, this isn't official or confirmed, but my estimation is we had perhaps up to 20 tornadoes across just this part of Missouri that night. But again, it was impossible to get out. If a tornado didn't hit anything, we weren't able to go out and confirm it, just radar signatures that we saw. So quickly looking at the Oak Grove tornado, this was, if anybody knows where Oak Grove is, it's just along the interstate, just east of Kansas City, eastern Jackson County. It went into western Lafayette County. Here's your supercell. Okay, if anybody is familiar with supercell structure, here's your hook echo right in here. And it's kind of hard to see, but your tornadic signature, rotation signature that we would use to issue a tornado warning just south of the interstate going through Oak Grove. If anybody knows what that big truck stop is there on I-70, we're kind of talking about that same area. Okay, did quite a bit of damage right there on the south side of Oak Grove. It's kind of tough to see this map, but tornado formed just south of Blue Springs, just east of Highway 7, kind of in the Lake Lotawana area, and trekked east, impacting the southern side of Oak Grove. Didn't go right through the heart of the city, so thankfully there. And then it went in through Bates City and finally dissipated just east of Odessa there, just south of the interstate. Okay, it was an EF3 tornado, which are pretty rare in these parts. Okay, then we went to, that same night, just a little bit earlier, was the Smithville and Lathrop tornado. And I call it the Smithville-Lathrop because it formed near Smithville and then dissipated up toward Lathrop. Now, I was doing this same spotter talk up in Clay County that night. I was in Liberty. And as soon as I heard all of the beepers going off, I had a little radar thing here. And as soon as I heard everybody's beepers and cell phones going off, I went ahead and ducked out of the auditorium into the basement. And as they say, when the meteorologist is running from the storm, you might want to keep up. So we went down into the basement and waited that one out. It missed the church that we were doing the spotter talk in by about 5 to 10 miles, just to the north. Did a lot. It didn't hit any cities necessarily, but it did hit a lot of rural structures, a lot of houses out along the Smithville Lake shoreline. And then again, this map is kind of hard to see, but and then it pushed off up toward Lathrop, and it dissipated just west of I-35 there. There's a gas station kind of at that Lathrop exit. And so this tornado was about 20 miles long, and it was rated EF2 with quite a bit of damage across those rural areas. Back to Johnson County, July 26th and 27th, quite a heavy rainstorm. Everybody remembers the Coach's Sports Bar water rescues that we saw on live TV. This is the car dealerships that are right there on Warnall and State Line. All those cars were submerged. Here's an aerial shot of kind of the same area, that Warnall and 103rd area. And of course the Coach's Sports Bar, which was under about 6 to 8 feet of water that morning. So here's a video of the radar as that storm came through. Now this is what we call training, storm training. Not training like you guys, but like training as in stacked up behind each other, kind of like a train. So you have all these thunderstorms that are moving across the same area of Kansas City. That took place over a 3 to 5 hour time span. So you get that heavy of rain occurring in the same spot for 3 to 5 hours. You're going to get some very large precipitation amounts. Those blue areas are about 4 to 6 inches of rain, and then that yellow area just inside of it is adding up to about 6 to 8 inches of rain that happened that morning. Caused record flooding along Indian Creek right there at State Line Road, and that record would only stand for a few weeks though, because shortly thereafter, I'll talk about that in a second. Tomahawk Creek at Rowe Avenue also broke a record. that day. Now, these sites haven't had a very long standing record, it's probably 20 years or so, but still, anytime you break a record, it's pretty impressive. Not so much severe weather, but we had the solar eclipse. Was anybody able to get out and see the solar eclipse? Excellent, excellent. It wasn't severe weather, but I remember just from my job standpoint as well as my own personal satisfaction standpoint, the stress involved with trying to find a place with no clouds and try to explain to people where you could and couldn't see the eclipse. But yeah, on August 21st, we did have that solar eclipse, went right over Kansas City, St. Joe, Kansas City area. And of course, those clouds were such a pain in everybody's rear. And then that night, we had some severe weather. We had more significant flooding. This is a rain gauge that one of our forecasters had set up in their backyard. 9 inches of rain in their backyard in Kansas City. Here's Indian Creek Parkway with some mail trucks underwater. The old red bridge at the Blue River completely submerged. And then it might be tough to see this image, but that's basically 6 to 9 inches of rain right across Kansas City. So it was a very wet year across Kansas City. I mean, not only had the severe weather, but the hydro aspect, the flash flooding was very impressive. It's hard to read this image, but this is showing the Overland Park area where we had widespread reports of 8 to 10 inches of rain, which of course would lead to more flood records. So Indian Creek at State Line Road broke its record from like 3 weeks prior to that. So bad year for the car dealerships. So December 4th, this was actually very recently. We had some thunderstorms roll through, and we had a tornado form just south of, this is Moberly right here, and it was an EF1, went right through Higbee and Rennick, if anybody's familiar with that area. Had some pretty significant damage. Now, this is a mobile home, and this is an EF1 tornado. Okay? So something that's going to be a theme as we go forward in this is how mobile homes handle even what we consider weak tornadoes. Okay? Same with vehicles. Car completely tossed and damaged, a motor home completely destroyed, and a mobile home that left only cinder blocks behind. Okay? That mobile home was tossed into a field way out of the frame. There was a person in it. They were injured. Thankfully not a fatal tornado. Okay, so a little bit of year in review. Again, that's more to kind of whet the appetite for the next 6 weeks that we're actually getting back into severe weather season. So, thunderstorms, what do they need to form? They do follow a set of rules. They don't, as much as it seems like they do because of our predictions, they don't just form spontaneously. They have to follow a set of rules. So one thing they absolutely have to have is humidity. That's why we don't have very many thunderstorms in the wintertime. It's too dry. But you have to have that humidity. So if you have those hot, muggy days in May and June, okay, that's the humidity at work. That's where we get that ability to bring in those thunderstorms. Okay? After humidity, you need some kind of front, some kind of boundary. That can be a warm front. It can be a cold front. It can be an outflow boundary. It can be a dry line. Okay, we don't see the dry line out this far east very often, but it can happen, and it does happen. Okay, so you need some kind of low-level wind shift or some kind of low-level convergence to get those storms to start, lifting up. And then you need some kind of mid-level energy. We're talking about 20, 30,000 feet in the air. If you have a big ridge sitting over the center part of the country, you're probably not going to get very many storms. But if you can get some kind of trough, some kind of weather-making system to move through, you can basically kind of set off that trigger. All that instability, all that wind shear then becomes a storm and severe weather. Now, wind shear is important mainly for severe weather. We get rid of our wind shear typically in the late June, July, August, early September time frame. That's why severe weather doesn't happen as often during the middle, dog days of summertime time period. We get the wind shear and the more severe weather in the March, April, May, and then early June. So wind shear is very important. All that is just it's a difference of wind speed and direction with height. So at the surface, you might have southerly winds, but at 7,000 feet, you'll have southwest winds. They're kind of working in this fashion, which allows storms to start rotating and create supercells, tornadoes, etc. Okay? One aspect that is really a thorn in our side for severe weather prediction is what's called the cap. I won't go into too much detail about the cap, but it's basically a layer of warm air about 7,000 feet off the ground. And that cap is what dictates whether we even have storms or we have blue skies. Okay, so a lot of times when we say there could be severe weather today, and you go outside at 6 o'clock and the skies are blue, and you're like, how can we have no severe weather? We don't even have a thunderstorm. Well, the problem with the cap is it's a yay or nay type scenario. You don't get a maybe when you're dealing with the cap. You're either going to get large and in charge thunderstorms, or you're going to get blue sky. Because what that cap is doing is it's preventing storms from even occurring in the first place, as opposed to ones that can actually get going. So a lot of times, these are what cause our busts, where we start predicting, oh, we could see some thunderstorms today, but it kind of depends on how the cap plays out, and causes a lot of friction sometimes. So life cycle of a thunderstorm, we've seen this a lot. Okay, so we start out with the towering cumulus phase, where you start to, it's basically on those spring days where you get those cumulus puffball clouds. Okay, they don't really, you get to 11 o'clock, 12 o'clock in the afternoon, you start to, it was clear sky, and then all of a sudden 11 o'clock, you start to see these cumulus clouds starting to form. That's your instability starting to come into play. Now, if the cap is really strong, that's as big as they're ever going to get, is something like that. Okay, but if the cap breaks, if the cap isn't very strong, then they grow into actual mature storms, where you actually get these updrafts that go all the way to the top of the atmosphere, 50, 60,000 feet up. And that's where you start to get the rain and the hail and the lightning and potentially tornadoes. Now, every thunderstorm goes through this in some form or fashion. Some go through it very quickly. If it's a single cell, mid to late summer day, sometimes this process takes place in 30 minutes. But if it's in May and you get a supercell, you can get a supercell forming in Pratt, Kansas, and not going into its dissipating phase until it gets to Macon County. Okay, and all parts in between are in its mature phase. Okay, so once you get to the dissipating phase, that's when it loses all of its ability to hold moisture, and it just kind of drops it all. And this is when you get microbursts. Anybody ever seen or been through a microburst? Okay, it's just basically where a storm collapses on itself. Think about a faucet in a sink. You turn on the faucet, and all that water goes down, and when it hits the basin, it spreads out very quickly. Same thing with a thunderstorm that's decaying. All that water, all that moisture, it can no longer be supported by the thunderstorm updraft, and it just comes crashing down. And once it hits the ground, it has to spread out. And that's what causes your microburst or your downburst activity. So just a couple of videos here. We're going to talk. I'm not going to talk a lot during this, but we'll look at some thunderstorm hazards, starting with straight line winds, going to hail, some flash flooding, lightning, tornadoes. So just a couple of videos here to kind of show you a few things about how thunderstorms behave. So a couple things to look at in this video. One, we not only have the really strong winds, but you have these trees being completely flattened. Now, I don't know what kind of trees they are. Sometimes silver maples, they don't last very long, or they're not very hardy. Bradford pears are also notorious for going down easily. But when you have something like this, it's really important to let us know what kind of damage you have. It's easy to get into estimates. Oh my gosh, it was 80 miles an hour. But, the damage, I've had people call up and say, we had 80 mile an hour winds. And I'll say, oh my goodness, what's the damage? And they'll say, oh, I don't see any damage, but I heard it through the vents. Like, I know 80 through the vents, and that was 80. And it's like, no, if there's 80, there's damage. Okay, so if all you have is an estimate, you're out in the field or whatever, you're in your car, estimates are fine. But if you have damage, that's really important to us. Okay? The other thing is, you saw the kind of damage there. Trees go down in strong winds, 80 to 100 mile per hour winds. Straight line winds can occur up to 100, even 110, 120 miles per hour. So just because you have a lot of damage, a roof gets blown off, or shingles, or trees go down, it doesn't mean it was a tornado. It could easily be straight line winds. We go out and survey storms all the time. I don't know if it's a war story thing, but people want to live through a tornado or what, but people say, oh, it was a tornado.
And we're looking at all the damages on one side of the house. If it's a tornado, it's all over the place. And it's just hard sometimes to convince folks that straight line winds can and do produce quite a bit of damage. Okay, so hail. I don't know exactly where this is. I'm guessing somewhere in Europe. It's on the beach. People here huddled under a tent. Doesn't look like fun. I also don't know exactly where in the U.S. a beach that gets this much hail. I'm sure it can. I'm not sure exactly where. Well, that's going to help. So, we're going to talk a little bit in the future about situational awareness. This would have really been helpful to be situationally aware if they had known severe storms were moving in. If they had a radar app or something they could look at and say, wow, there's a big storm with a warning coming in. We should probably not be in the water or trying to hide under a towel. So we all know how hail forms, right? I remember as a kid going, how does hail form? It's 100 degrees outside and there's ice falling. Well, way up in the air, it's not 100 degrees. It's much colder. And so what you have is you have your thunderstorm. It's strong updraft. It's kind of suspending that rain. Ultimately, that rain freezes, kind of like a lottery machine, right? It freezes that rain, and it just keeps accumulating more and more ice until it becomes heavy enough that it falls back through the updraft. Now, the largest hailstone that has been recorded is 8 inches in Vivian, South Dakota. I'd be willing to say that that's not the largest hailstone that's ever fallen. That's just the one that was found. Got to also think it probably melted a little bit after or between when it was falling and then when it was found. So pretty amazing stuff. I mean, you can get hailstones that big. Okay, those people were lucky that it wasn't that big. Flash flooding. This is always the one that gets everybody a little tripped up. We see it every year. Water rescues across Kansas City and these hydro events where you have all this water. Most of it is preventable. People drive through flash flooding all the time, and it's just mind-boggling to me that we still have people that try to drive through flash flooding. It's just not a good idea. You're going to get stuck, and then it's going to cost emergency rescuers to come and get you, or maybe even they can't get to you. Okay, so just don't drive. I'm not going to spend too much time on this. Don't drive through flooded roads. It's not a good idea, especially at night. You can't see how far it goes, how deep it is. Even if you say, I've been on this road 1,000 times, you don't know if it's washed out. Okay, so just don't drive through flash floods. Don't be outside. There's a couple lightning videos here just to scare you, not going outside.
That jumped right over my head.
Look at this person. No hiding. So, as Trent said, I do like to go out and look at storms and photograph them. The tornadoes never scare me. The hail doesn't scare me. I know where I can see the tornado. I know where it's going to be. The hail, I can sit in my car, and as long as I got glasses on or something in case the glass breaks. Lightning, you have no clue where that's going to go. You have absolutely no clue. If you're outside and there's lightning, there's no ability to avoid it. So basically just don't be outside during lightning. It's just not a good idea. If you can hear thunder, it's close enough. There's what's called bolts from the blue, which is where thunderstorms will actually, the bolt of lightning will go horizontal for 5 or 10 miles and then go down. So you can actually have blue sky, and a thunderstorm that's 5 miles away can actually strike your location. So again, if you can hear thunder, now who's ever heard of the 1 second equals 1 mile thing? Okay, it's not on here, but this is a personal mission of mine. It is not 1 second per mile, it is 1 mile for every 5 seconds. Okay, that's how the math works out. So if you say, oh, lightning, 1001, 1002, 1003, 1004, 1005, bang, that's not 5 miles, that's 1 mile. Okay, if you get to 15, that's 3 miles. So if you get to anywhere under 30, okay, if you count and you get to 30, and then you hear bang, that's only 6 miles away, and that is well within range to strike you, okay? So if you can hear thunder, it is close enough to strike, even if it's blue sky above you, okay? No such thing as heat lightning. I grew up in the desert, and my parents would always say, oh, look at the heat lightning out there. There's all the monsoon stuff out in Nevada and Arizona. And it was probably until I was 18 and realized that heat lightning doesn't exist. It's just lightning that's far enough away that you can't hear the thunder. You can see them on your hot summer nights, which is why there's a thing called heat lightning. So that doesn't exist. Tornadoes. So Pecos Hank is going to show us a few tornado videos here. Okay, these are the main attraction for thunderstorms, right? This is what everybody thinks of when they think of supercells, tornadoes. Okay, they have to be in contact with the ground. Okay, a funnel cloud isn't a tornado, not a tornado loft, it's just a funnel cloud. Okay, just because you don't see a condensation funnel all the way to the ground doesn't mean it's not a tornado either. So the thing to make sure if you do see a tornado or a funnel cloud is to kind of look at the ground and see if you can see some debris swirling around. And more Pecos Hank here. Pretty impressive video, if you ask me. We got a storm chase tour right here. You pay money and they drag you like a quarter mile from a tornado. I don't know if that's a good value or a bad value. I don't know if you're getting your money's worth or what. Yeah, there they are right there. They're all standing out there watching the tornado. Okay, we got one more here. Pretty impressive tornado. I don't remember which one this is, but it's a very wide tornado. If you can, try to keep your eye on this high tension wire right here. It's kind of hard to see. It's very dim. But if you watch it here, it actually goes tumbling down in the tornado. There it goes. You see it? Yeah. Thanks, Pecos Hank. Okay. EF scale. Here's what the stats say. I have one problem with these stats. Okay, it's a stat that says 83% of all tornadoes are EF0 to EF1, which are in the 65 to 110 mile per hour range. One thing to keep in mind when we run these stats is that rating does not equal wind speed. Rating is just what we use to indicate how much damage the tornado caused. So in this particular case, EF0 to EF1 by rule means it didn't produce very much damage. So if you have a large tornado in central Kansas, it's going to be rated an EF0, regardless of how strong it was, because it doesn't hit anything. It takes out some wheat, some corn, whatever, and that's it. Well, some of the most recent Doppler on wheel studies, Doppler on wheel, the truck with the radar on the back, okay, you see it on TV occasionally. Most of the tornadoes they have sampled have actually been in this EF2 to EF4 range, okay? Now, I'm not bringing this up to besmirch the stats, but I do want to bring it up in the context of I don't want people thinking that if a tornado is heading toward them, that it's got an 83% chance that it's going to be a weak tornado and it's not that big of a deal. I would venture to guess that this number is much bigger and this number is much smaller in reality. Okay, now the stats can't back it up because, again, the ratings are based on damage. And as we all know, when you have a tornado in eastern Colorado or eastern Wyoming, it's difficult to actually impact something. So it goes on the record as an EF0, or in some cases an EF1 if it's able to take down a telephone pole or something like that. Okay, so I want to drive home the point that if it is a supercell tornado, it is most likely in this EF2 to EF3 category, despite the low percentage. So thunderstorm spectrum, this is just a way of saying that you have You have a single cell, you have a supercell, which are the two ends of the spectrum, so the weakest to the strongest, and then you got everything in between. So we as humans like to categorize or classify everything. Everything has to be in a bin. Well, in reality, storms don't really go into bins very well. They're almost kind of hybrids of each other. Supercells that kind of have a multi-cell structure to them, or multi-cells that are built up of a bunch of single cells, okay? So looking at the single cell thunderstorm, this is something that you see in the mid part of summer, the dog days of summer, as we say. You have the moisture, you have the humidity, and you have that buoyancy to get a thunderstorm, but you have no wind shear. The winds aloft at 20, 30,000 feet or maybe 10 miles per hour. So the thunderstorm, it builds this updraft, it produces all this rain way up in the atmosphere, some hail, and then drops it right back through the updraft. So you have these competing processes going on. You have the downdraft with the rain and all the hail, and then you have that updraft, and eventually it'll just choke itself off, and it doesn't do anything. So these are pretty benign, if you ask me. It's got some lightning and thunder, so you have those problems. You have some heavy rain occasionally, but you're not going to get a tornado out of them. There's no rotation. You might get some wind, microbursts, that kind of stuff. So then you get to multi-cell cluster, which is just a bunch of those single cells, right? It's just a bunch of them mixed together. Now, this is what we see the most here in Kansas City, okay? And a lot of times you have the supercells, the real bad rascals, off in central Kansas, eastern Kansas, and by the time they make it to Kansas City, they've kind of all mushed together into one line of storms or one big blob of storms. And they're the ones that wake you up at 2:30 in the morning with all that lightning and all the heavy rain and everything. So the multi-cell is probably what we deal with the most in this area. They're, again, pretty benign, aside from the lightning risk and some heavy rain. You're probably not going to get a tornado from them. You can get some wind, but really, again, not too big of a problem. Another type of multi-cell is what's called a squall line. We all know what a squall line is, just a line of storms. Okay, that's usually along a cold front or something like that. QLCS is just an abbreviation for quasi-linear convective system. Now, the reason that's important is because a QLCS can sometimes produce these very brief, but sometimes pretty potent tornadoes. You can't see them because they're kind of buried in rain. But your tornado threat with these types of systems is actually pretty moderate. It's not zero, but it's also not like the supercell, which is the king bee, the T-Rex of the thunderstorm spectrum. So all hazards maximized. Your supercell they're semi-rare around here. We're too far east for them to get really frequent in this area. Again, you're talking mostly in the high plains of Colorado, out into the central plains of Kansas, and then from Texas up to the Dakotas. By the time you get to about the Missouri River, you're looking at a transition zone from the supercell to the multi-cell cluster. But we do still get supercells. And if you do have this structure, again, these are the structures that we always talk about. You got this rain-free base under the storm. And the reason you have a rain-free base is because you've got that strong updraft. And if there's wind shear, all that precipitation up in the upper atmosphere gets pushed away from the storm, and it deposits it out in front. Okay, so we'll see a few photos that show this pretty well. Okay, and if you have that ability, that updraft doesn't have anything to fight. It has an unimpeded persistence as it moves east. So when you have this rain-free base, it means this updraft has nothing fighting it on the downward side. So it can just keep going forever and ever and ever until it either hits a stable layer or loses some wind shear or whatever. Okay, so we have a supercell here. Then we have a rain-free base under here, striated updraft. Okay, that's your first clue that it's a supercell. Okay, it's got these striations. You can't actually see a supercell rotating. It's too big. And so even though it might be rotating 150 miles an hour, it's still too big for you to really see it well. But you get these striations, that's your cue. Now, shelf clouds also have striations, but if you're looking at a cloud that's going from horizon to horizon, it's likely a shelf cloud and not a supercell. So don't let that fool you. Okay? If you see something that has a pretty finite spatial domain, you're probably looking at a supercell if it's got these structures. Okay? Here's a video of a supercell. This is sped up, so you can see this rotation. Okay? So you see it spinning like a frisbee or a spaceship. Okay, I'll play this a couple times just because it's cool. Okay, so you have this rain-free base. Now there's a little bit of rain coming through here, but generally speaking, it's not too much. Okay, the bulk of your rain is being deposited out in front. So here's your updraft. Okay, if you're going to see a tornado, it's going to be in this area, not out here. Okay, so here's your rain-free base, and again, it's rain-free because you get one more time. There we go. It's rain-free because it's got this updraft. It's pushing all that precipitation away from it and depositing it out here, so it has nothing impeding it anymore. Okay, so that's how you get those supercells. Okay, here's a wall cloud. Now this is in real time. It's actually, you can actually see it kind of ingesting this warm, moist air out here. Now this is a bit of a tricky one because I'm seeing this wall cloud very close to the ground. The closer to the ground that wall cloud is, the better chance it has of producing a tornado. Okay, if you got a wall cloud way up in the air, it's to 10,000 feet, probably not going to get a tornado out of it. Look at this thing. It's like 500 feet off the ground. And I see this out here. Now, it doesn't say tornado, but I'm saying that looks suspicious to me. I'd look right over there. And if I recall, this does look very similar to the Dodge City supercell tornado that occurred 2 years ago back in May. So we'll see how this thing evolves. But this area here is very suspicious to me. I would think that might be actually a tornado. But one thing also to kind of keep in mind, you have all these little fingery clouds. It's really easy to look at something like that and get scared and say, oh my gosh, that thing is big and bad. And it is big and bad. You should be scared of that. But all these ragged fingers, those aren't funnel clouds. Now, you need to watch them. They could be developing into a funnel. But if it's this ragged, it's probably not a funnel cloud. But this over here, boy, that's pretty laminar. Now, when you're looking at the difference between say a scud cloud and a funnel cloud, you're looking for laminar versus, kind of ragged. And over here I'm thinking ragged, but here I'm not thinking ragged. Okay, another wall cloud. Kind of hard to see it, but so big wall cloud right here, rain-free base. Okay, all your precipitation is out here. Okay, here's your big updraft. Okay, so if you're looking out there, you see a storm, and you can see the sun or blue sky underneath it. Okay, that's a good indication that you're dealing with a pretty strong storm it's suspending all that precipitation and depositing it away from the storm. So this looks like the same wall cloud, right, that we just saw. So this says now wall cloud 2 tornado. So I'm going to say this is now your tornado. Kind of on the back side of this wall cloud. Thinking this is probably the Dodge City storm from May 24th, 2 years ago. But at any rate, you're always looking for this wall cloud. Now this is really zoomed in, by the way. So you're not really seeing, but this is your whole wall cloud right here. And then you have this tornado. Okay, so you're always looking for that wall cloud. Now, you can also see, which is kind of cool, I'm not going to talk about it too much in this show, but we have what we in the biz call rear flank downdraft right in here, where you can actually see kind of a clear slot kind of eating into the backside of that storm, that wall cloud. So that rear flank downdraft, it's kind of a clearing on that backside. If that shows up, it's actually a pretty good indication the storm is trying to go tornadic. If you watch it for 10 or 15 more minutes, you might actually see a tornado with it. So always something to watch when you see that wall cloud. If it starts to eat away on the backside of it, give it about 10, 15 more minutes and see what it does. So tornado myth busting. I'm just going to go through these really quick, okay? Tornadoes don't hit big cities. False. Okay? They do hit big cities. They hit Dallas. They've hit Salt Lake City. They've hit St. Louis. They've hit Raleigh. Joplin, I don't know if you consider Joplin a big city, but it's pretty large. Tuscaloosa, Birmingham, doesn't matter, it hits big cities. Okay? Tornadoes are attracted to mobile homes. Big joke, right? They are. The tornadoes are going to happen wherever they're going to happen, but you have perhaps some areas that are more vulnerable, larger mobile home density. If you go into the deep south, there's a large mobile home population there, so there's just more of them, easier to hit type scenarios. Also, the optics. If a mobile home gets hit, as I showed earlier, an EF1 tornado tosses one into a tree, it gives these really dramatic videos and photos so people pay more attention to them. That same tornado hits an established house, lose a few shingles, nobody cares. But if it hits a mobile home and tosses it a quarter mile, everybody cares. So we all take note, if you will, of mobile home impacts. So probably that's how that myth perpetuates. Tornadoes can't cross water. They do. They cross rivers all the time. Some cold bodies of water they may struggle, so like Lake Michigan or just any kind of body of water that holds a water temperature of less than, say, 70 degrees. You might have some struggles to get it across that, but I mean, don't go to Chicago and say, that thing won't get to me. Okay? Tornadoes we'll just say they don't care about topography. They don't care about topography. As you can see from this tornado, it's going down a hillside. I lived in Topeka for a little while, and the legend was when they built Topeka that Burnett's Mound would protect them. It was a kind of a Native American legacy that Burnett's Mound kept us safe from the tornado. So they built Topeka, and on June 8, 1966, F5 tornado went right up and over Burnett's Mound, right through downtown Topeka, killed about 15 people, which for an EF5 or for an F5 I think is actually kind of a low number, but it still did a lot of damage. Catastrophe for Topeka, went right up and over Burnett's Mound, which was supposed to save them, and didn't care. And then whatever myth that you have. Any Tonganoxie dwellers? Tonganoxie split, right? Yeah, it doesn't exist. People think I live in Tonganoxie, so storms won't get to me. They follow the interstate. I live in Norman. I got the Norman bubble. Fill in the blank. Your city has a myth. Okay? Don't follow it. It can happen. Tornadoes go wherever they want to go. Okay, so SCUD and SLCs. Anybody know what SLC stands for? Yeah, we have some repeat people here, right? Yeah, SCUD, I don't know what SCUD stands for actually. But SLC is scary looking clouds. That's our more biz terms, right? In the biz. All right, so scary looking clouds. That's where you have, you see a shelf cloud, it's going over your head, and you see these kind of fingery, dangly clouds that kind of look like they could be a tornado, but they're not. Okay? So, don't be fooled by SCUD. Don't be fooled by scary looking clouds. The best advice that I can give as far as being able to classify a scary looking cloud versus actual scary cloud, like a funnel or a tornado, is just give it a few seconds. Watch it. Kind of let it marinate a little bit. If it's a funnel cloud, it's going to persist. It's going to be laminar. You can actually see the rotation with it. If it's a fingery cloud, it'll get sucked up into the storm. You can see these clouds don't last very long. They're ragged. They don't look like tornadoes. Okay? So, if you were to give me a picture and say, is this a ragged SCUD cloud or is this a tornado? I might have to shrug a couple of them off. And the reason I say that is because if you have a video, 5-10 second video, I can see it and say, oh, well, obviously SCUD because it's not there anymore. So, give it a few seconds. 5-10 seconds. I mean, you don't have to call us right away and say, oh my gosh, I got to oh, wait, never mind. Click. Yeah, just give it a few seconds. Okay? So these are some videos that we'll kind of look at to say, what would you be thinking when you saw that tornado or SCUD cloud? Okay, so part of a supercell, it's not. It looks like outflow. Okay, so it looks like it's pushing away from you. It looks like clouds being developed along the edge of an outflow boundary. They're not rotating. They're not persistent. They might be kind of skimming over those hilltops, but otherwise they're not in contact with the ground. So what do we got here? Photos are the toughest ones. Like I said, people always show me a photo and say, what do you think, tornado? I mean, sometimes you can tell, but sometimes you can't. So I'm looking at that going, a couple things. Obviously, it's a funnel. Okay, it's nice and laminar. It's part of a supercell. Is it persistent rotating? Well, we don't know. It's a static image. Okay, but let's just go with it. And then is the debris cloud touching the surface? Who knows? Can't really tell. I would say this is kind of unofficial guidance, but if it's halfway to the ground, it's probably got a ground circulation. So if you estimate a funnel cloud halfway to the ground, it's probably a tornado. Now, we would prefer before you call it a tornado and report it as such that you're able to identify a ground circulation. But just speaking from experience, it's probably a tornado if it's halfway to the ground. Okay, so let's get this baby in motion here. And what do we have? Now we have a tornado, right? We have a little ground circulation here. It's well past halfway. It's kind of an elephant trunk tornado. Okay. And of course, more tornado. Part of a supercell, yes. Persistent rotating, absolutely. Debris cloud, yep. Okay, situational awareness. There's two aspects of this to really hit on. I won't spend too much time because the video's kind of funny. So situational awareness it's two-pronged. One of those prongs is when you're out looking at storms, be aware of your surroundings. A lot of times these storms, they cycle. They have a tornado and it's dissipating, and then the second tornado is forming. Anybody remember Pilger, Nebraska from a couple years ago? They had 2 tornadoes at once. Okay, it's pretty rare, but it happens. And what happens is if you're looking over there, you're like, I got the tornado, I got that rain-free base of wall cloud, I got it. You got another one forming right above you, okay, because that storm is cycling up a new updraft. The last thing you want to do is be watching this thing 2 miles away, thinking you're doing a really good job of staying safe, and then you get a tornado that drops right basically next to you because it's forming overhead. The other part of situational awareness is making sure that you're aware of what's going on weather-wise. And the subsequent slides to this will talk about where you can find a lot of that information, the weather resources. So watch the video. If you get grumpy at people texting, you'll love it. The people that looking down at their phones, bumping into people. Turn around. I don't know where they found all these videos. Look at this guy. He's not even on his phone. Poor guy.
And pay attention. Come on.
Anyway, all right. A little comic relief. So, how do we stay situationally aware about what's going on with the weather forecast? Well, in the 1 to 3 day range, so in that time period, we don't have the ability to really nail down a forecast in the 1 to 3 day time frame. In that time frame, we're looking at the pattern and we're going to say, boy, there's a chance for some storms on Tuesday. And we might be saying this on Friday, okay? But we're not going to get into any specifics. We're not going to talk about tornadoes. We're not going to talk about anything in specific. We're just saying, hey, there's a chance for some storms. So in this 1 to 3 day time frame, it's kind of an outlook. It's like, okay, this is something that we're paying attention to. We'll put something on Twitter, on Facebook. Talk about, hey, if you got plans this weekend, think about alternatives. All right? We have on our webpage the situation report, which anyone can access. We do it specifically for emergency management, but anybody can access it. It's a public reference for what kind of weather we're expecting over the next 5 to 7 days. Okay? And the closer we are to an event, the more detail we'll get into it. It comes in the form of a PDF packet, so you can actually download it if you wanted to and archive them for whatever reason. Okay? So we put them on these PDFs, and Trent, do you like them? Where'd he go? He's not even in the room. Boy, we're going to nail him for this because I referenced him and he's not here. All right, so anyway, these are built for emergency management, but if you're in part of a spotter network, if you're even just a weather enthusiast, check them out, and you get some information from them. So, SPC outlooks. Everybody familiar with SPC outlooks? Storm Prediction Center. Slight, moderate, high. Okay? So this is an outlook that goes out to 7 days for how much they think the severe weather is going to form. Okay? So it goes from 0 to 5. Okay? General thunderstorms all the way to high risk. Now, high risk, I don't think Kansas City's been in a high risk since 2004, okay? Maybe 2003, I can't think of those 2 years mixed up. So we dwell mostly in this range here, the slight to enhanced. And that's basically what we're talking about, scattered thunderstorms versus numerous thunderstorms as far as severity goes. Okay, so sometimes on the news, they'll say, oh, we have a slight risk out, or an enhanced risk. It's a scale of 1 or 0 to 5, if you will. With if we're in a high risk, just go to the basement for the day. It's probably for the best. Okay? Watch phase. Okay, this is the day of an event. So if we're in a tornado watch, severe thunderstorm watch, that means conditions are right for thunderstorms. Whether you're talking about severe winds, you're talking about severe hail, If we're thinking tornadoes aren't all that likely, we'll go with a severe thunderstorm watch. If tornadoes are likely, then we'll go with a tornado watch. Okay. Now, this is the time you should probably be thinking about a plan. Okay. Now, I'm not talking about building a plan. Okay. That's what the next 6 weeks are for. Okay. I want you all to come up with a plan. If you have kids in school, are you going to take them out of school for a tornado watch? Okay. That's up to you. It depends on if you live in a mobile home. Do you want to get them into a safer structure? If you are in a mobile home, the next 6 weeks are really important for you because there is no way that you can be in a mobile home, get a warning for a tornado or for a severe thunderstorm, and be able to take action. Okay, unless your development has a specifically designed shelter that you can get to in less than a minute. Okay, the last thing we want people doing is getting in their cars with a tornado warning and trying to drive and miss it. Okay, because if you're in your mobile home, that's bad, right? Your mobile home's going to be tossed. Okay, so the watch phase is when you should be thinking, okay, do I really want to be in this structure? It doesn't have to be a mobile home. I'm kind of hammering on mobile homes, but it can be a modular home. It can be a temporary structure. It can be if you're on a construction site and you have those little boxy trailers. Okay? Doesn't matter. Any vulnerable building, you need to be thinking about what I'm going to do when we get put in a watch, because in the next couple hours, we could be dealing with something pretty bad. Okay? Again, I talked about severe thunderstorm watch. Anytime we're thinking severe thunderstorms are likely. Tornado watch, flash flood watch, same idea. Okay? And then we get into the warning phase. Okay, now we have a storm on the radar. We have spotters telling us, hey, I've just picked up a hailstone this big, and we're putting it in the warning. Okay? This is too late. If you're in a permanent structure, you should probably be thinking about getting into your basement or in your interior room or whatever. But if you're in a mobile home or any kind of vulnerable structure, it's probably too late to really do anything useful. So you should have already been taking action when it comes to this warning phase. Okay? So that means severe storms are actually happening. Okay? Don't plan on getting 15 to 40 minutes of warning time either. Okay? That's our goal. And you think about it, a storm is moving from here to here. Well, if you're on this end of the box, sure, you get your 30 minutes. But what if you're on this end of the box? Okay? You're getting 5, maybe 1. Okay? So severe thunderstorm warnings go out if we think 60-mile-an-hour winds or 1-inch hail. Tornado, obviously, if we think there's a tornado. Flash flood if there's waters or roadways being washed out. Okay? Quick survey question. So you have tickets to an outdoor event, call it a concert, Royals game, whatever. And the forecast says you listening to your favorite TV guy, and they say thunderstorms are in the forecast for tomorrow. What should you do? Okay. Sell those tickets before everybody catches on. Depends on how scared you are of thunderstorms. Ignore the forecast. It's always wrong anyway. Nobody picked that. I'm taking license plates. Keep your plans for now, but check in the theater or stadium or whatever sheltering plans and postpone. Which one do you think? 1?
3.
Yeah, 3. Who said 2? I heard it. You're lucky this light's right in my face. I can't see very well. All right, yeah, 2. I don't know who put that in there. I didn't do that. So weather apps, I'm sure everybody's got their favorite weather app. I can't really endorse any, but yeah, I have a few on my phone too. Try to get automated methods of receiving. Some apps do, some apps don't. Try to see if they'll deliver a warning to you. Okay? WEA alerts are actually really important. I know some people get a little queasy about government tampering with their phone. But I think these are really good to have. I mean, I don't think they're doing anything bad. It's just sending warnings to you. You get tornado warnings and you get flash flood warnings. You can opt out. You can go to your phone settings and hit government warnings and they'll turn it off. But if you haven't done that, it's on. So anytime you're in a tornado warning. The reason I like these better than what the apps do, a lot of the apps are county-based. And so if you're in Johnson County, you can be in, near Lewisburg, and there's a tornado warning for somewhere up by Olathe, and you're going to get that warning, okay? And you may not be in the warning, but you're going to get it. Whereas with these WEA, they're going to take it off the cell phone tower. So whatever cell phone towers you're connected to, if that's in the warning, it'll deliver it to you. If those cell phone towers are not in a warning, you won't get it. So it's a little more refined, it's a little more precise if you go with these, but like I said, if you want to turn it off, that's fine. Other warning methods, weather radio and sirens, pretty archaic if you ask me, but some people still use them. Sirens, that's for Trent to discuss. Media, obviously that's probably the most popular way of people getting warnings. They'll turn on their TV and listen to, I highly recommend putting a TV where your safe place is, whether it's in a closet or in a, but now you have so many apps streaming news now, you probably don't need all that. You can probably get your news inside wherever your shelter is. So have media there. They'll be able to tell you when a storm has passed your location or how much further it has to go. Okay? And then there's various others. If you want to do a Google search and just look for weather apps and warning methods, go for it. So weather safety before a storm, we already talked a lot about this, so I'll kind of just breeze through it. Situational awareness. Check out all those packets that we send out and social media. Follow us on Twitter. We're funny. We are. We're geeky, but we're funny. Check us out on Facebook. If you don't do the Twitters, do the Facebooks. So check out those forecasts. Know what's coming. Make a plan. Between now, it's going to still be cold all week. There's no tornadoes, I promise. Okay? Now make that plan. So if you have a business and you have employees and you want them to behave a certain way in a tornado watch and you want them to know what to do, make that plan now. If you have kids, okay, do a tornado thing. First one to the basement wins a game or something. I don't know. Okay. What to do during? Tell you what, anybody who's had to mow their lawn in May around here knows that if you don't get it done one day, the grass is going to be twice as big. So when the tornado's out there, you just got to do it, right? Yeah, don't do that. I don't know why that's in here. That's such a bad example. That was in Canada, by the way. I think that was in Canada. All right. So severe thunderstorm warnings, tornado warnings, as we know what to do in those, right? Go to your basement. Go to the interior room. One thing I'm not a big fan of is the whole mattress thing. Have you ever heard to put a mattress over your bathtub or whatever? Has anyone tried to move a mattress? I mean, in a tornado warning, I don't want people doing this down the hall. I mean, just get to where you're going. Get to your basement. I mean, if you got blankets and pillows, by all means, throw them on. But the mattress thing, I never got it. King-size mattress, really? All right, mobile spotting safety. This is really important. Okay, this is kind of geared toward the chasing thing. One thing I always do when I go out is I always have backups for everything. Yes, my cell phone is great, but I'll tell you what, in northwest Oklahoma, there's not a lot of cell coverage. Okay, so you need paper maps, you need ham radio, other ways to get information. Last thing you want to do is be stuck on an intersection and you have no information of what's coming. You have this big black cloud coming. Okay, don't get yourself in a situation where you can't get out. Don't go down a dead-end road with a storm behind you. Okay, so just kind of common sense. Don't lose situational awareness. Okay, and then after, let's say you are in a structure that gets impacted by a tornado. Okay, don't come screaming out going, da-da! And then the lightning comes in and takes you out. Or the power line, you're walking around in your sandals and you step on a power line or something, okay? So just be very careful when you come out, if you come across damage or if you come out of damage, okay? There's lots of nails and I don't care if you're wearing steel-toed boots. Nails don't care, they'll go right through. So gas leaks is another thing, okay? Things can explode. Spotter reporting, I'll breeze through this, pretty simple. Just tell us where you're at, what you see, what time it happened. Okay, so in hail, compared to sports balls or coins, because those are pretty standard, right? Baseballs are pretty standard. Tennis balls, golf balls, quarters, nickels, dimes. I had one person call in and say they had marshmallow-sized hail. Lucky Charms, there's the s'mores, right? Were these big marshmallows? It forced us to ask more questions. Tree damage, right? Was it a Bradford pear? Was it a silver maple? Was it healthy? Did it have leaves? A lot of questions. Okay, it makes a difference. Wind, tell us what the damage is. Like I said, if you have to give us an estimate, please do. But it's almost always wrong. It just is. You say 60, it was probably 45. You say 70, it was probably 60. So, but the damage is what's important. It took down my metal building, or I got a big tree that's now smushed my car. Tornado, pretty self-explanatory. Okay. Flash flooding, please don't drive through it. I can't say that enough. But not only don't just stop when you call us and say, okay, road AA is flooded out. Call your law enforcement, call 911, whatever, so that they can get out and block it. Especially at night, people driving along. Right? Okay, what would you report on this? So we got a truck. So we got these little fingery clouds. I don't see much there, to be honest with you. We'll do it again. Okay, we got something suspicious back here, but it's not really doing much, not rotating. So what do we got here? Probably some scud, or I wouldn't report this. We don't need to hear about scud. Okay? So I wouldn't report anything here. I just enjoy the storm. So what do we call this? Shelf cloud. Yeah. This is outflow. Okay, and again, if you got outflow, you got cold air. Cold air does not equal tornadoes. Okay? So it's not rotating. See a shelf cloud. I don't know if I saw any scud, but what? Sorry, I'm going to try to go back here. So on this particular instance, on the leading edge of these shelf clouds is typically where you're going to see a lot of that fingery, kind of scuddy type clouds. And those are the ones that really throw people for a loop, and they call us and say, oh, I see a shelf cloud and I see a funnel. You're not going to see a funnel and a shelf cloud together. You're just not. I mean, unless the shelf cloud is part of a supercell, and that's a whole different situation. But around here, most of the time, if you got a shelf cloud and it's moving with this cold air, you're going to see these little kind of dingly clouds, but they're not funnels, and they never will be funnels. So just kind of keep that in mind. If you see a shelf cloud, chances are it's a decaying storm. It's pretty harmless. It might have some wind behind it, but that's about it. Okay, so we got another one here. Sorry. So we got another one here. Horizon to horizon. Another shelf cloud. Okay, and we don't need to hear about shelf clouds. They're harmless for the most part. If you'd love to take a picture and send it to us on Twitter, we'd love to see it because we are geeks and love that stuff. But we don't need it for warning purposes. So I would report this. All right. So again, I want everyone to be proud of being a spotter, getting us on Twitter. Okay, you don't necessarily have to be a part of a county. If you have access to interface with the National Weather Service, just let us know what you see. Just I always say a picture's worth 1,000 words, and Twitter only gives you 280 characters. So you can do 4 tweets to tell us the story of one picture. Okay, so take a picture, send it to us, follow us on Twitter. It's really cool. Like I said, we're funny. I promise. There's a phone number here. It's on that card. I'm going to kind of zoom past this. So if you only get to the 4, that's fine. Just get one of those cards. Either put it on your fridge, put it in your phone, whatever. But that gets right to a meteorologist. You might even get me on the phone. All right? Oh, Jeopardy. Reporting methods. My favorite, personally, is Twitter, because we're always monitoring Twitter. It's a rapid-fire thing, so we'll see if you're out and about and we see hail, and it'll pop up right on our screen, and we'll be able to see it, and we tell the warning forecaster, hey, someone on 135th and Antioch just gave us this thing, and they can come around, oh my gosh, it's a golf ball. Put it in the warning, okay? Spotter Network, if you're familiar with some of the real geeky chaser type stuff, Spotter Network is there. Cocoa Rods, if you want to do a search and look it up, it's more for like snow and rainfall amounts. Obviously, there's MPing. You can go to your app store and download an MPing app, MPING, and you can report to us through that. But Twitter is my favorite. I think that's the most useful. Okay. So, never assume we already know something is happening. Okay, let us know. Worst case scenario, we'll say, okay, thanks, and probably move on if it's something that we don't have much use for. Okay. So I think that's it. Beautiful cloud. This was taken by one of our forecasters in our office. of Kansas City skyline with the shelf. I'm going to stand a little to the side here so I can see everybody out there. I also want to know who picked 2 earlier. All right. So, if there are any questions, I'd be happy to answer anything. Yeah, blue shirt. Well, Kansas, the state, has been hit by several EF5s. I believe the most recent one would have been Greensburg back in 2007. But since then, there have also, 2016, there was a storm out by Chapman that just barely missed Chapman and Abilene, which I suspect was an EF5, but it was actually rated as a 4, again, because of the damage. So Kansas actually gets some of the strongest tornadoes anyone's ever seen. Now, Kansas City, the strongest tornado that happened in Kansas City was back in 1957, so about 60 years ago. It went through Ruskin Heights. Anybody know where Ruskin Heights is? Right, about Grandview, kind of Lee Summit area. Okay, that area was completely obliterated in 1957 from an EF5 tornado. So that was the last time we've had anything like that go through the area. Yeah?
So in Johnson County, I would assume, but I don't want to assume, so I'm going to ask, the radars are close.
Yeah. Yeah, Johnson County's in a great spot for radars. You have Topeka's radar, which is in Alma, Kansas, just west of Topeka. It's between Topeka and Manhattan. And then you have the Pleasant Hill radar. And both radars are about 40 to 60 miles apart from, or not apart, but from Johnson County. So that's kind of in a nice little sweet spot. Because if you get too close to a radar, you see all the bottom parts, but you don't see the top. If you're too far, you see the tops, but not the bottom. So when you get to that 30 to 50 mile range, you actually get a really nice sweet spot. So Johnson County is actually in a pretty good spot. There's also what we call a terminal Doppler weather radar up at the airport. It's actually in Dearborn, Missouri. And it's designed to watch for microburst activity near the airport. So we actually have 3 radars for the Kansas City area. So actually in a really good spot. Yeah?
Is there an age limit to who all can call in and say if they see a tornado?
No. I mean, no. We'll never say, oh, you little kid, you see a tornado. So the question was, is there an age limit for reporting tornadoes? And I would say absolutely not. Now, if you're a child and you call us, you might catch some skepticism, I'll be honest. So it'd probably be better for all involved if you had a parent call in. But if you're a teenager or something like that, I mean, we're probably not going to question it, so long as it's a valid report. Okay? Yeah. White shirt, KU. Are they winning, by the way? Has it started? The KU game. Yeah, go ahead. I mean, I can't comment on it a lot. That's a weather. He's asking about the Torcon, which is a tornado condition index. That's done by the Weather Channel, and it's a very similar index to what the Storm Prediction Center does. So the Storm Prediction Center, I gave you the slight, moderate, high, slight, enhanced, moderate, high scale, but they also have quantitative values where they actually put percentages on how likely tornadoes are to occur, say in Kansas City, and they'll maybe say 10%, 15%, whatever. That means a lot to us, but I don't expect it to mean much to the audience. Because if I said there's a 10% chance of tornadoes in Kansas City, you'd probably be like, okay, isn't that like every other day? But actually 10%, if the Storm Prediction Center says 10%, we're like calling people in because we got to get a lot of people into our office. So bringing it back to the Torcon, what the Weather Channel has done is kind of built their own very similar index, except they kind of go 1 to 10. It's kind of like, on a scale of 1 to 10, how likely do you think tornadoes are to form in this part of the country? And they basically put it on that scale. So it's essentially the same thing. Unofficially, I kind of like it better because people understand 1 to 10 scale. They understand if you're saying today is a 7 for tornadoes, I'm going to take some plans. But if you use our system, which is 10%, which is a big number, It probably doesn't get people all that interested. So my only comment on it is it's probably a little more understandable to the public than what we use internally. Yeah.
What's the average rotational velocity of a wall cloud? Or just what's the period?
You know, your rotational velocity is typically, I mean, it's a range. Some of them rotate pretty slowly, so maybe in your 30 to 50 mile per hour range. And then, but if you have you have a very strong wind shear, very strong instability day, it can rotate as 200 to 300 miles per hour. The El Reno tornado back in 2013, the one that killed a bunch of storm chasers, was essentially a wall cloud that just went to the ground. So everybody's calling it this 3 mile wide tornado. And I mean, we can debate terms all day, but it was essentially just a wall cloud that made it to the ground. And it was rotating about 300 miles per hour, and it got to the ground, so everybody just calls it this 3 mile wide tornado. So again, we can split the hairs on terms all we want, but so to answer your question, it's a wide range. They happen. You can even get a wall cloud in a storm that's not rotating. So really, you can go from 0 to 300 miles per hour. But in the big boys, the big supercells, you're talking at least 100, possibly up to 300 miles per hour. Yeah.
It's 15 to 4, Katie's winning.
Oh, thank you. Thank you. Excellent.
But it's still early in the first.
Yeah, I know. They'll probably blow it. Yeah, over there.
What's the difference between super res and base?
Oh. Say that last part again. Sorry.
Especially for someone that's like kind of amateur.
Yeah. So the question is, what's the difference between super res radar and base radar? You can have it either in reflectivity or velocity, and I think this is referring to some of those weather apps like Radar Scope or Pickle, depending on which phone you have. And what you have, the super res is, I mean, it is exactly that. It's like radar but high definition. The data is a lot higher for those, so sometimes your phone might struggle to bring in that kind of data, so you'd switch over to base velocity or reflectivity, which is a smaller data packet, but the resolution is not as good. So if you're in a rip-roaring internet area with good Wi-Fi, there's no reason to not look at super res. It's like the definition between high def TV and standard def. There's no reason to watch standard def TV if you have the option of high def. So really, the only reason you would even have base reflectivity or base velocity is if you're in a data sparse area. Okay, so but on a radar app, if you're looking at high res, a lot of them only have high res base data. You don't have storm relative data. I'm not sure why that is, but that's just how they've done it. So have I answered your question? I kind of flip-flopped between two different things. Okay. Yeah, super res means the radar information is really high density, and then base is just, it's like blocky, like old Nintendo. Yeah, right here, green. Yeah.
How many tornadoes have multiple vortexes like the one in Omaha in 76?
That's a good question. I don't want to say all of them. Tornadoes are built off of multi-vortices. So all of them, probably not. You probably have some that are single vortex, such as like a land spout or a really weak tornado. But if you're dealing with anything of substance, anything real beefy, if you will, and I know that's very vague and it's just not a good term. But anyway, if you see a well-formed tornado, it has multiple vortices in it just by its pure structure. So I